All right, welcome to this video on solving multi-step equations with variables on both sides. So we're building on the last video where we learned to solve equations that did have variables on both sides. Now we're going to deal with some equations that contain some like terms, some distribution, so that we can, this is the end all and be all of what we want to be able to do with equations here. So I'm going to draw my vertical equation wall so that I can make sure that I keep things organized. We always do that first, okay? All right, so before we can solve the equation, we want to turn it into one of the easier equations like what we had in the previous lesson, where you just had something like with a variable and a constant on one side, a variable and a constant on the other, which means we need to clean up each side of the equation. And when we do that, we're going to have some distribution and we're going to have some like terms. We're going to distribute first because distributing is multiplying, and that comes before adding and subtracting like terms. Be very careful with your signed integer rules. So 3 times x is going to give us 3x. 3 times minus 5 is minus 15, plus 2x plus 7. And then on the other side, I have this negative 1 right here that I have to distribute. It's not the 9 because it says 9 minus, not negative 9 times. So 9 and then negative 1 times x is negative 1x. Negative 1 times positive 1 is negative 1 plus 14. All right, so I have done distributing. Now we are going to work on combining some like terms on each side. So I'm going to look over here. I have a 3x and a positive 2x, so that's going to give me 5x. I have a negative 15 and a positive 7, that's negative 8. Then on the right side, I have this negative 1x, and I don't have any other x's to combine it with, so I'm just going to write it down. 9 minus 1 is 8, and then I add 14 to 8, and I get positive 22. So now my equation looks like a equation with variables on both sides, but it doesn't have any other mess. So I just need to go on and do what we did in our previous lesson, which is move all variables to one side with addition and subtraction. I recommend that you move the smaller one to decrease the amount of negative numbers you have to deal with. So negative 1x is smaller than 5x, so I'm going to move it over to the left side rather than moving the 5x over to the right. So that cancels away to 0. This is 6x, 5x plus 1x, minus 8 equals the 22. Now the next thing is that I need to move all constant numbers to the other side. See, now this is a two-step equation that we did in the lesson before the last lesson. So I'm going to move my constant numbers to the right, to the opposite side of where the variables are. Those cancel to 0. I have 30 equals 6x. And now I have a one-step equation, which was the first lesson we did in the unit. I'm going to divide both sides by whatever's multiplied by the x so that I can get my solution of x equals 5. Okay, so that's that one. We solved it. We're not going to check this one, but we are going to check the next one to practice the skill of checking our answer. So we have another one where we're going to follow the same steps. Distribute, combine like terms, each side separately. You don't do a single inverse operation until you're done cleaning up the left and cleaning up the right. Then you do an inverse operation to move your variables all to one side, to move your constants to the opposite side, and then finally to divide away. So we are going to do this one where we solve and check. I'm going to give us some space here. Now, I would recommend that you pause the video and try to solve it on your own. And even if you already did it in your notes, you could write it on another piece of paper, like from class. And then come back and watch and make sure you got it right. Otherwise, I'm going to go ahead and solve it right now. Okay, so I'm going to look at the left side. I do have some distribution I can do first. 6x minus 6 and then minus 3x. Here I have a -1. I can distribute. 4 minus 1x, and then -1 times +2 is -2. Distribution done. Next, I combine like terms. So I have a 6x and I have a -3x. Make sure that if you're circling your like terms or highlighting them, that you circle or highlight the sign to the left of it because it has to be included. So 6x minus 3x is 3x. And then I have that -6 I need to write down. Over here, I have a -1x. I don't have anything to combine with it. Second, my pen's dying. Okay. So -1x. And then I have a 4 to combine with a -2. So 4 minus 2 is +2. Next, I'm going to bring my variables to one side, moving the smaller one, which is -1x. So I'm going to add 1x to both sides. Again, not how you have to do it. You could -3x over to the right. I just prefer to reduce the amount of negative numbers I have. Those cancel away. Since I moved my variables to the left, I need to move my constant numbers to the opposite side. That would be the right. Those cancel away. So 4x equals 2 plus 6, or 8. Finally, I divide to get the variable isolated. I get x is 2. So now we need to check that answer. I need to take my answer of 2 for x, and I need to put it in place of every x in the equation. So I'm going to write 6 parentheses. I'm going to leave a space to put my value of x in. So I'll get a different color for it to make it stand out. So the first place I'm going to put the x is right here. So my x is 2. That's what I got. So I'm plugging in 2. -3 times x right here. So I got to put the x there. And then over here, there's an x in the parentheses. So I got to put my x value of 2 there. So that x value of 2 went in all three places. I'm still going to use my equation wall because I don't want to combine things on the left with things on the right. We're not solving again now. We're just simplifying. Okay, we're not doing inverse operations. We're just doing PEMDAS. So let's work that out and see what we get. PEMDAS, we do inside parentheses first. 2 minus 1 is 1. And 3 times 2 is 6. And then, well, I'm not going to write that down yet. I'm going to follow it very strictly. All right, inside parentheses, 2 plus 2 is 4. All right, now I'm going to multiply because numbers written in front of parentheses mean to multiply. 6 minus 3 times 2 is 6 equals 4 minus 4. And yes, 6 minus 6 is 0. 4 minus 4 is 0. So that checks out, which means my answer of x equals 2 is correct. Okay, so now we're going to apply this to some situations. There are two types of application problems that we're going to look at with this. They are not the only types, but these are the main two, and they are the ones that people tend to have the most issues with. So that's why I like to make sure I do those in the notes as examples. The first one is the equal perimeters problem. This comes from your NJSLA test this year that you'll be taking at the end of the year. And let's run through it. So we have a situation where we have a rectangle and a square that have equal perimeters. Remember, perimeter is adding up all the sides. The length of the rectangle is 12 more than its width. Okay, so right now we're talking about the rectangle. And we did translating words to expressions. The length of the rectangle is 12 more than its width. So we're going to use W to represent the width of the rectangle. So we can write 12 more than its width. So W is going to be the width of the rectangle. And 12 more than its width would be 12 plus the width, or the width plus 12. You can write it either way because addition is commutative. So that means the other two sides are going to be the same as their opposite sides because we know that a rectangle has opposite sides congruent, 12 more than the width. All right, now let's look at what they say about the square. the side length of the square is twice the width of the rectangle. Okay, so the side length of the square, which the square has all four sides equal, is twice the width of the rectangle. So it's twice the width of the rectangle. And a square has all four sides the same. So those are the four sides of the square. Now, if we look back at the first sentence, it said the rectangle and square have equal perimeters. So I'm going to write down the perimeter of the rectangle equals the perimeter of the square. That's my equation I'm going to solve. So I'm going to make my equation wall. Okay. It wants us to find the area of each figure. That's what it says at the end. We're going to come back to that. Okay. We can't find the area until we have the length and the width to multiply. And right now we just have W. So we're going to get the numbers and then actually go back and find the area. So the perimeter of the rectangle is when you add up all the sides. There are three ways you could start your equation, and I'm going to show you all three. Way one is if you list them all out. If you say, I'm going to add 12 plus W plus W plus 12 plus W plus W, and you write them all down. I'm going to do the top and the bottom. Now I'm going to do the left and the right. Okay, that's one of the ways that you could write the perimeter of the rectangle. Another way would be like, okay, I have two of these, so I'm going to write 2 times 12 plus W. And I have two of these, so I'm going to write 2 times W. 2 times the length plus 2 times the width. That's another way you could start your equation off. A third way you could start your equation off is to add them up, the like terms, in your head as you write it down. So you could be like 1W plus 1W plus 1W plus 1W. That's 4W. And then 12 plus 12 is 24. All three of those are acceptable ways to write your equation. And I'll tell you right now, if you were to combine like terms on this or distribute and combine like terms on this, then you would end up with this anyway. So start either one of the three ways that is comfortable for you. Now let's look at the square. Again, you could also start it three ways. You could say, I'm going to list out adding up all four sides. Okay. That's one way you could start it. Or you could start and say, well, I'm just going to do 4 times one side because there are 4 sides. Or you could add them up in your head, 2W plus 2W plus 2W plus 2W, and combine the like terms as you write it down and go straight to 8W. So again, it could be any of those that you start with, which is why we include this in the multi-step equations, because depending on which way you think to start it with, you might start with some distributing and like terms in your equation. But once you get that simplified, you are going to do your inverse operations. Okay, see how you have just an 8W here and a 4W there? You need to get your W's to the same side. So that cancels to 0, and I have 24 equals 4W. And then I will divide by 4 on both sides, and I'll get that W equals 6. So we now know the width of the rectangle is 6. Okay, which means the length, 12 plus 6, is 18. So the area of each figure, the area of the rectangle is length times width, 6 times 18. You can write the dot or the parentheses to indicate multiplication. You get 108. We don't have any units, so we don't have to worry about that. Now let's do the area of the square. The area of the square, well, each side is 2 times W, and W is 6. So 2 times 6 is 12. Again, you do length times width. So that's 12 times 12. That's 144. Okay. They did not ask us to go back and find the perimeter, but let's just do a what if scenario. What if they did ask us for the perimeter? Well, for the rectangle, you would add 18 and 6, and then this side would be 18, and this side would be 6. So 18 and 18 is 36, and the left and right adds up to 12. So the perimeter of this would be 48, because that's what you would get if you added all four sides. Remember, perimeter is adding sides, area is multiplying two sides. Here, if you added 12 and 12 and 12 and 12, you would get 48 for the perimeter. So just in case they were to ask that. So there's our perimeter and rectangle equal problem. You do have one of those on the homework worksheet. Now let's talk about consecutive integers. I'm going to teach it the way I know that the high school teachers are going to expect you to know it next year. So everybody does it a little bit differently, but I'm going to go with the true and honest expressions that will get you through any level of mathematics. Okay, you have to understand what consecutive integers mean. Consecutive integers are one after another. Okay, consecutive generally means one after the other. So for example, if I were to ask you what are some consecutive numbers or integers or whatever, you would say like 2, 3, 4, or 5 and 6, or 21, 22, 23, 24, 25. There can be any number of them. The problem will say how many you have. It'll say you have 3 consecutive integers, or 2 of them, or 5 of them, or whatever. But they're one after the other. So if the problem simply says consecutive integers, these will be the expressions you will use, because the first number is x. The second number is 1 more than the previous number. The third number is 2 more than the first number, because if you take this number and you add 1, 1 and 1 makes 2. If you add 1 to this to get to the next consecutive integer, you get x plus 3, and so on and so on. So x plus 1, x plus 2, x plus 3, however many you need, you stop. If it tells you you only have 3 consecutive integers, then you will just use the first 3 expressions. If it tells you you have 4, you will use those. If it tells you you have 5, then you're going to have to add in x plus 4 and keep going until you're done. All right, so those are consecutive integers. The next kind is consecutive even integers. All right, let me run through the explanation on those. Every even integer can be divided by 2. Every even integer is a multiple of 2. So every even integer can be represented as 2 times a number. So the first even integer is 2x. So let's say we had some consecutive even integers like 10, 12, 14, and so on and so on. Those are consecutive even integers. To get from 10 to 12, you would have to add 2. That's why we say the next one is 2x plus 2. To get from 10 to 14, you would have to add 2 twice, so you'd have to add 4. Then if we did 16, we'd have to add 1, 2, 3 times. We'd have to add 2, so we'd have to add 6, and so on and so on. So those are the expressions for consecutive even integers. And then the last one, consecutive odd integers. Every odd number is 1 more than an even number. So since I use 2x to represent my first even number, I say 2x plus 1. If you're at an odd integer, like let's say 5, and you go to the next odd integer, you have to add 2 to that to get there. That's why if we take 1 plus 2, we get our next odd integer, which is 2x plus 3. And then if we add 2 to that, we get our next odd integer, which is 3 and 2, 2x plus 5. And then so forth and so on. Add 2 to that, we get 2x plus 7, and so forth and so on. So that is your expressions for consecutive odd integers, and you use as many as you need. So make sure you pay attention to whether it says consecutive, consecutive even, consecutive odd, and use the correct expressions. Usually on assessments, at least on your checkup and your mid-unit quiz, I will have you match these on it. That way, then you can use it to help you with the question that you're doing. but by the time of the summative, you should know them. All right, so let's do a problem where we are using these consecutive integer types. It says the three sides of a triangle are consecutive even integers. All right, that's the green one that I highlighted green right here. All right, I'm going to draw a triangle. So here's my triangle. All right, so consecutive even. So the first one is 2x. The next one is 2x plus 2. These are the side lengths of the triangle. The third side is 2x plus 4, and I get to stop there because I only have 3. I don't need any more expressions. Then it says the perimeter is 96. Perimeter is when you add up the sides of the triangle. So I'm going to add up the side of 2x. That's this one. Then I'm going to add the side to that, 2x plus 2. And then I'm going to add the third side, 2x plus 4, and it's supposed to equal 96. Solve an equation to find the length of each side. All right, it's a multi-step equation because I have distribution-like terms. I don't have variables on this side on this one, but you have a consecutive integer problem on your homework where there is going to be a variable on the other side. All right, so I'm combining my 3 2x's to get 6x. 2 and 4 makes 6. So this is just a two-step equation. I can subtract 6 on each side. 6x equals 90, which means if I divide by 6 on each side, x is 15. Now that is not any of the side lengths of the triangle. The question asks us to find the length of each side afterwards. So I'm going to take my value of 15 and plug it in. One of the sides is 30. Then we have 32. Then we have 34. So the triangle has side lengths. It's a word problem, word answer of 30, 32, and 34. Okay, so now you have examples of those kinds of problems to use. That is the end of this lesson. Join us for the next one where we are going to start working with equations that have special solutions that aren't just single numbers.